When I had my first expedition to the coastal areas of Canada, I was prepared for everything, but I was not prepared for the unexpected. We had solved the problem not to get the samples too hot, but they had to prevent it from freezing. So we used bean cans because we had nothing else, warmed them up and stored the samples. Another problem here was, how can we keep the very expensive, very complicated machinery running in sand with very low electricity? If the centrifuge breaks down, we would not have any way to finish our study. Not to talk about logistic problems to get the samples from Canada to Germany. I was refocused with this problem as professor at the University of Potsdam when we had a study in Laos where we measured vitamin A levels in blood. We tried to facilitate this and we changed it, but we could not avoid centrifugation and we still had to solve the problem to bring the samples from A to B. This was basically the birth of bioanalyte. I realized that solving the problem of analytic was not a simple step of modifying steps in between. We had to solve the problem to bring the samples from the place where we take them to the analytical laboratory. We had to change the laboratory and bring the laboratory to the place where we can analyze it. And only this way we can prevent that a good and healthy nutrition is limited to those societies which can afford it. We need this analytic at the site where we can do it by the people who need it. And when we did this, we get a seed financing and we had to finish the project, but the project was not running very well. So we had to find another way. We had to come up with a different solution, and on this way we found an unexpected way how we solved the problem. Funny thing is, the feed industry was jumping on it, and we suddenly had an assay to improve fertility in cows. How did we solve it? We had to replace a laboratory with equipment worth of $100,000. To shrink it, no centrifugation, no pipetting, no cooling chain. Everything was necessary to reduce. And so the problem was how to do it. And we came up with a solution which we could not believe ourselves at the very beginning. So simple it was. We developed vials where we had to put in the samples and we had not to centrifuge. We just shaked it, not stirred it. And the sample separates, the sample we're extracting the components, and we were using latest LED technology to detect what we are looking for, because vitamin A has the very phenomenon, it glows in the dark. So using LED technology was the solution to one solution to our problem. But not all samples were equal. You have seen the question on oil. When we went to edible oil, we could not use the fluorescent, so we had to move into a color reaction, and this color reaction shows you nicely that vitamin A is present in the oil. Using modern and novel development of optical systems, we were able to transfer this test in a quantitative assay. 5 years after we started the analysis and started the experiments, we came up with a ready product, which you can see here, and which has been introduced into the market. And we were amazed that a small vial as small as this, with a value of $5, can substitute a whole laboratory with $100,000 worth. And the simplicity of the assay, you can imagine if you can say it can be done in 5 minutes. And even my 5-year-old children can do this test at the spot. So we were able to transport complex analytic to the places where we needed it, avoiding complex logistic and the global transport chain. This is an example where iCheck is used in Kenya. 100 samples of blood has been analyzed. Data were ready the moment they have been analyzed. If we would send them to a laboratory in Germany or the US, we would have to wait until now to get it ready. With our system of analytical power to the local places, we can bring all stakeholders together. Food producers can use the analytic to check what they are doing and how they are doing it. NGOs can check their programs, can check how the program is progressing, and governmental can check if people are doing what they're supposed to do. This is an example of the Food and Drug Administration in Ghana. Here they decide whether the vitamin A in the oil is sufficient or they should return the vitamin A fortified oil, which is not sufficiently fortified. So all levels are ready to use this system. And if you finalize the question I was addressing, then you have to have the final question is everything we are doing really making an impact? We had this in the morning, the discussion. Can we measure efficacy? And if we do so, we can measure with our system the population of need and can see really it improves the situation. Everything is nice, still academic. What are the numbers? Because numbers count, as we have learned. And I would like to give an example. If you would analyze 1,000 blood samples in a study in Kenya, what would be the consequences? First consequences, can we be faster? Yes, we can be faster. For the classical analysis, we estimate roughly 150 days, logistic, transport to whatever, to get the final results back. If you do the 1,000 samples in Kenya itself with the local analysis, you will be done in 15 days. You have the result, everything is ready. Costs. The whole study, including infrastructure and logistic costs, would roughly be, it's an estimate, $75,000. Our analytical would cost $5,000. So you have a difference of $70,000 extrapolated by the many studies which are currently running. There's a lot of money left to be used by others. Coming to the end, I think for scientists it's a very rewarding point to see that an idea gets into a final product. And we have something at hand which we can give to those who really need it. Thank you.